Okay, so what we're going to focus on today are hypothesis tests. Primarily, though, what conclusions can we make from a hypothesis test? This can be pretty tricky, so make sure you pay attention. So, pretty standard problem here. We're looking at a bottle filling machine. It's supposed to dispense 12.1 fluid ounces. So that's what we believe it should be doing right now. And then what we're doing here, we're going to randomly select 4 bottles and see if our machine is manufacturing these bottles correctly, if they're filling them correctly to 12.1 fluid ounces. That's what we're trying to figure out now. Is there convincing evidence? Is there convincing statistical evidence that the mean amount is different? So again, is different is also a key component. So you can see here, during an hour, we selected 4 bottles, which had a mean of 12.05 fluid ounces and a sample standard deviation of 0.085 ounces. So we're going to perform a test of significance. So let's go through some of the main things here first of all. We have to have our hypotheses. It's called the null hypothesis, which we write as H sub 0, and the alternate hypothesis, H sub A, but for today, I'm just going to call them Ho and Ha. That's what I tend to call them. So Ho would be that the true mean amount is 12.1 fluid ounces. In other words, the bottle's working correctly. Now with Ha, it'll also be mu, it'll also be 12.1. This value here and this value here should always stay the same. Ho is always a test of equality. Now down here we have to go back in the problem and realize, is it a greater than, less than, or not equals to? And what we can do is come back here, is different. So we don't care if it's more than or less than, we're just saying, is it not equals to? So our null hypothesis, the mean amount of juice dispensed is 12.1 ounces. Our alternate hypothesis, the mean amount is not 12.1 ounces. Now, this is another key component. The conditions for inference are met. So we're saying it's a random sample. We're saying that this is approximately normally distributed or sampling distribution. So we're good to go with that. So what we can do now is actually run the test. And I went ahead and already put this into our calculator. And you can see here, I'm using a TI-84. And we're using 12.1 for mu, 12.05, sample standard deviation, n equals 4. We're doing not equals to, and we're going to go ahead and calculate it. And this is some very important information here now. I'm going to grab this. Let's talk about what this tells us. This tells us that we ended up with a t-value of negative 1.17. This p here is our probability value. I recommend writing PROB equals instead of p equals. PROB was 0.3242. Now, what we're doing here was we were not given a level of significance, so we're going to compare that to 0.05, which is our alpha. Now here we can see that 0.3242 is greater than 0.05. So what that means is we get a large probability. In other words, this is pretty common. So we get a large probability. So what we're going to do is we're going to fail to reject Ho. Or we can also say there's insufficient evidence to accept Ha. I like this one more whenever we have a large probability. By the way, I teach my students, if you have a tiny p, reject the Ho. And if you have a large p, you fail to reject Ho. So again, tiny p, and tiny is when you compare it to alpha. So when you have a tiny p, reject the Ho. So for us right now, we have a large probability. We fail to reject Ho. There's insufficient evidence to accept Ha. So what we can say is there is insufficient evidence to say the mean number of fluid ounces is different than 12.1 ounces. So again, there is insufficient evidence to say that this would be accepted. And that's it. Be very careful. Don't say the machine is working correctly. Don't say we accept Ho. That is very wrong. It is not correct. It is not statistically correct. What we're saying is either we failed to reject Ho, or probably a better way to say it is there's not enough evidence, there's insufficient evidence to say that Ha is true. I hope this helps. Be very careful about what you say. And as always, if you have any questions or if you have a request, don't hesitate to contact me. Take care.